Okay. So let's see if we can dig in. I'm going to ask some questions. I'm going to ask everybody a question. So let's see. Lakshmi, you first. Ladies first.
Okay, thank you, John.
Do you think 10%, 50%, 100% of code coverage is good in testing? What's a good code coverage percentage?
Uh,
Is 100% good?
Let me see. Factory.
No answer?
I feel actually it's good. I
Un-
can't say percentage. It's good
Okay.
actually. 100% good.
Okay. Ashok, 100% good? What do you think?
If you can achieve 100%, it's really good.
100% is really good. Okay.
Yeah, but it's not necessary.
Okay. Hemant, what do you think? Hemant, what do you think?
Yeah, what I feel is like even 100% is not sufficient actually. Code coverage is just you can have certain amount of protection against regression, and it's just for um, basic testing. But no, even 100% is not sufficient. You cannot address all the flows anyways. But you can try to have maximum coverage, at least whatever code that humans have written.
Okay. So this is what I think.
25%, do you think?
This is what I think. Is 100% good? Yes and no. And 50%? Yes and no. And 25%? Yes and no. So here's the story. 100% code coverage locks you in. You cannot move without breaking tests. And I mean you can't move without breaking tests. You can do nothing practically without breaking a test. You can't call another method. Think about that. So if we have public void do something, and then we say bar some other class equals new some other class, some other class dot do, that will break, this statement will break 100% code coverage. And the thing is, I think that's bad. Not only do I think it's bad, I think it's horrifically bad. So when do I think 100% code coverage is good? Well, I look at categories of services or code. And this is what I think. Low level code that is called all over the place. 100% is good. Normal services that promote business rules, 100% code coverage is really bad because you can't move. Now, what do I mean about low level code? Low level code means for example, frameworks. If I screw up frameworks, then I screw up everything. So that would be bad. Things in the CPI namespace, our enterprise service bus, the poker manager, things of that nature, 100% is good because every line of code you write in there is called millions of times. So, yes, if I do this, it breaks lots and lots of tests, but that's worth it. Normal services, not even close. We don't want 100%. What percent do I think is good? I can't put a percentage on it. I really can't. What do I think is normal? Probably about 40%, 30 to 40% is probably normal. I don't know for that for a fact. I would have to look at some statistics, but the testing that I do in my code is going to be it's going to be different than the testing that you do in your code for the most part. Take this for example. So if I write a test for this method, what am I trying to do? Well, I think I want to test only one thing. Is some other class, no. How many times does the do method, how many times is the do method called from the do something method? And that is the only thing that I can test. Therefore, if I do this, if I write a test to check this, and it should only be called once, and I change it to some other class, do the other thing, this test breaks. Now, does that add value? I say it doesn't unless it's low-level code. I think it hurts you, actually. But if I were to look at some other class, do something, do the other thing method, and in there, I'm doing something like returning an int, and I say, return 10. I think that testing the fact that return 10 is really important, and it should be tested. And with this kind of statement, I would argue that we should get near 100% of these statements written, but not near 100% of these statements written. As it turns out, consequently, these are pretty easy tests. These are pretty hard tests. Why? Because the only way to verify that do something that the do method was called here was to mock the some other class and to mock the do method. And then we can ask the mocking framework to check how many times the some other class was called. And if it was called 0, then we fail. If it was called twice, then we fail. It's got to be called exactly once for the test to succeed. Okay, second philosophical subject. Let's say we have software whose lifetime will span 5 years. And let's say that we've written, 100% code coverage is 5 tests. Test 1, test 2, test 3, test 4, test 5. Okay. And over the lifetime of this test, test 1, test 2. So this was green. This turned up green 5 times because we've tested it 5, and red 0. And this, let's say, that's turned up red twice. Okay. Lakshmi, you first. What can you tell me about these 5 tests? Does anything jump out at you?
Uh, Test 1 green, test 2, 3, 4, 5. These are 4 different test cases, John.
Yep. 5 different test cases.
Huh.
Anything jump out at you?
No.
Okay. So, in terms of my return on investment of each test, was test 1 worth writing? Do you think?
I'm sorry, John. Test 1.
Yeah. Do you think it was worth writing? Do you think it was smart that I wrote test 1? Did I get my
Yeah.
money's worth? Did I get my money's worth out of test 1?
Yeah.
Okay.
Test 1, it's
Okay. Because remember, each test costs me money, right? Every
yeah.
test, let's say the developer time costs me money because it's time. So you think it was worth writing test 1? Ashok, what do you think? Do you think it was worth writing test 1? Lakshmi, you can mute yourself.
Let me unmute. Yeah.
Lakshmi, you mute yourself.
Lakshmi, mute.
I'm thinking.
She's thinking for an answer. Okay. So test 1, yeah, it may not be because out of this 5 years, and it has really not shown us any error. So
Okay. So Ashok, let me ask you the next question. Are you
Yes.
are you cheating right now?
cheating? No.
Because you've heard me talk about this before, haven't you?
No, definitely not.
Really? I'm impressed.
Yeah.
Okay. So
Because we had a different discussion, John. So yeah.
okay.
But I remember we had a discussion, but it was a different discussion. Yeah,
Okay. All right.
I get the point.
Okay. So here's my contention. That test 1 and 2 and 4 and 5, I got no return on investment. So if this cost me $10 and it's never turned red, and this cost me $10 and it's never turned red, I got nothing out of it. Some would say, hey, but wait a minute. You were allowed to refactor with confidence. You were allowed to, you were allowed to give QA software that works. Well, this test didn't help me. This test didn't help me do it. This test didn't help me do it. The only test that helped me refactor confidently, or the only test that really paid off, is the ones that turn red, not the ones that have turned green. These have been a total waste of money. Okay? So then you start to ask, if you believe me and you agree with me that the only test that was worth writing was the one that turns red, your next question should be, how do we know? Over the life of software, how do we know which ones... Mute yourself, Ken. Thank you. How do we know which ones are going to turn red, and how do we know which ones are going to turn green? Well, we really don't. It's a game of experience It's a game of probabilities. When I write code that's 100% code coverage, I'm not only increasing the possibility that I will be wasting money, I'm also locking myself in and costing me lots of money if I ever had to refactor. They say, and it's true, that tests help you refactor because after you refactor, you can run the test and see if you're all green. Well, in 100% code coverage, when you refactor, you're gonna get 100% red. None of them gonna turn green. Or comparatively speaking, you're gonna get a lot of red. So 100% code coverage is I do it sparingly. There is a sweet spot of code coverage that you will find in your code when you will say that's enough. Okay. I'm telling you right now that I am a huge believer in testing. Huge. Next question, Hemant, for you. Do you think it's good that we deliver defect-free software to QA? You think that's a good thing or a bad thing?
What do you mean by defect free? Like zero defect
Zero defects.
software release?
Software we release to QA has zero defects. You think that's good or bad?
Yeah, it's good. Of course, why not?
It's extraordinarily bad. It's not only, it is incredibly bad. Okay, now why do I make such a crazy statement, right? I make such a crazy statement because in order for development to deliver defect-free software, then they basically have to do what QA would do. They have to test and test and test and test and test. And I say this, we're going to test and test and test, and we're going to get our defects down from 100 to 50 to 25 to 0. And that's going to take a lot of time. Then QA is going to do the exact same thing and not find any defects. So this effect becomes true all the way up to QA. If they're testing and they're spending 1,000 hours testing software that has no defects, right? ROI on QA is 0.00. And ROI on dev approaches 0.00. Not 0, but it approaches 0. Because if we took a piece of software that took us an hour to write and test it for 20 hours and fixed all the bugs and then push it over to QA, then our return on investment starts to approach 0 and QA's is 0. So turning over software to QA that has 0 defects is bad. We wasted all kinds of time and money. If you think about that in isolation, you will have no way of disagreeing because it's not opinionated. It's simply mathematical. It is mathematical.
Yeah. But just one. Yeah. Just one thing, John, here.
Yep.
Hello?
Yes, I can hear you.
So, first of all, I just, answered your question, but I completely know that there is no software which will be, defect free actually. Because if it is, I personally believe that if it is defect free, then it is probably not tested properly.
No, I could
But
have. I
when you
just
have,
go ahead. Guarantee you that's defect free. I can write defect free software. Sure, I can. I can write it. You can write it too.
yeah,
There's,
it
that.
depends on the size.
Sure, yeah, but that software, I can write defect free software. Absolutely, I can write
Mhm.
software very, very easily. You just saw me do it, right? That's one of those statements that we hear all the
Mhm.
time that just simply isn't true. There's only a cost. It's only a matter of this, Hemant, dollars, right? How do we spend?
Yep.
We have $5. How do we spend $5 for the best ROI? This is not theoretical. This is real because I don't think I've worked for many companies that said, spend all the money you need. Don't worry about it. No, we always have to make decisions based on probabilities. I'm probably not even going to test this. I probably won't write one test to test that method because my confidence of that working is 99.99% approaching 100%. So I'm not going to spend $1 testing that. Not a dollar. Now, you know, the test bigots would say 100% code coverage. You need 100%. That's not 100. No, baloney. That's theoretical. That's not reality. That's not taking into consideration the business of writing software. We're developers, we're engineers, but at the end of the day, we're paid to be productive. And the company only has so much money, so we have to think, each one of us has to think about what is the best way for me to be productive today. And I promise you, it's not to write this test. And I promise you, it's not to get our tests, our bugs down to zero. Now, does that mean I want to produce software that has a million bugs? No, of course not, because my return on investment has been inverted the other way. Now my return on investment of my software approaches zero, but for very different reason. So what I'm saying is this, is that we not only have to apply good development and engineering practices to code creation and architecture of software, but in all other aspects of what we do during the day. All other aspects, because it all goes into a matter of how do we best spend our dollar. And it is not by writing defect-free software. It just isn't. Okay. So there's another one of those. It's not what you don't know that will kill you. It's what you think you know that's true that isn't. Right? So how do we know then where our sweet spot is? Hemant, yes.
John, can you be a little louder because somehow like I'm not able to hear your volume level is very low on my machine.
Okay. Is that true of Lakshmi? Is that true of you too? And Ashok, can you guys hear me fine?
Yeah, 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 I can hear you, John.
Yeah, we
It's
can hear.
sometimes it happens.
One moment. Let me check this. Hemant's laptop could be an issue. Let me check that.
Oh, okay. I'll pause for a moment.
Yeah. It's actually full on my machine. This is also full. Yeah, it's full.
Everything is full.
Yeah.
And I think your this one because your mic volume when you speak is low.
Yeah.
Try this.
Yeah.
Testing. Testing 1 2 3. Testing 1 2 3. How's that, Hemant?
Still they're doing testing.
Okay.
Hello.
Hemant, you there?
Yes, he's testing, John.
Okay.
Is it detected yet? Wait, I think you need to disconnect and reconnect. This device has to be detected.
Yeah.
It's a USB device. It's still detecting.
Can you just tell him that I'm using different device now?
I hear him.
Yeah. Thank you.
Yeah, here it's at this. Yeah.
It has taken PC till that time.
No,
Yeah. It's there.
those two has to. Detected.
Lakshmi, talk to me.
Yes, John.
How you doing?
Yes, I'm doing good.
Your mic.
Actually, we started analyzing that global reports data in database.
Okay. Good.
Yeah, we are doing that work. After that, we will start creating of services and all. That time, we might need your help, so that we will call you when we create services and all. That.
Okay. So your mic is not giving me any static. So are you in a different part of the building than the rest of them?
No, John. I'm in the same building. I'm sitting next to Ashok.
Okay. All right.
But I'm in different
She's
network.
Okay.
she's using a pretty advanced USB headphone, John.
Oh.
No, John. I'm using supercomputer.
All right, then Ashok, whatever headphones Lakshmi has, everybody has to get. Where did you get those? Where did you get them?
No, that's what the IT team is ordering for us. Everyone, once they get their laptop, they will be getting that.
Okay, because on my end, I can right now it's good, but sometimes it's just I can't hear myself think. So we have to get everybody set up properly.
Yeah.
Okay. All right. How's Hemant doing?
I've given him my headphone. He's still configuring it, I believe. Let me check with him again.
Okay.
Can you hear me?
I can hear you.
Hello?
I
Yeah,
can
great.
I can hear you.
Yeah. Hello.
Okay. Can you hear me okay? Testing 1, 2, 3?
Yeah.
Okay.
Yes.
Great. All right. So let's then mute because I'm still getting a lot of static from you, and we'll continue.
Okay.
Okay. Great. So just to wrap up this part of the conversation, I guess, you know, I believe that everyone should come to work in the morning thinking, how am I going to be most efficient with my time? Where does my value add lie? And let me execute that to the best of my ability. At the end of the day, we want to create the best software the most efficiently, and we want our return on investment to be the highest. That doesn't necessarily mean no defects. It doesn't necessarily mean 100% code coverage. What it does mean is we continuously have to think about the best way to produce and the best delivery model that we can create so that the company gets the most out of the money that they're spending on our department. If you start to think in those terms, you can't help but become more and more and more efficient. You're not only a team member, you're an extremely important team member in this department. So what you do has a direct and profound effect on the return of investment of the department. Okay, let's take a look at a test. A first look at a test. We utilize a pattern called AAA. Hopefully you're familiar with that. And basically, AAA stands for Arrange, Act, Assert. First part of the test, we arrange. Second part of the test, we act. Third part of the test, we assert. Let's start by looking at a test. Let's look at the name of this test. One person once told me that naming is the most important thing that you can do. You know what? I don't know if I'm all the way there, but I'm pretty close. Naming is one of the most important, if not the most important thing that you do during a day. I will stop and think for minutes about a name. If I don't like that name, I will type it and type it and type it and type it until I get a name that makes sense. That name is your documentation. Remember I said I don't like documentation because documentation goes stale? Well, names don't go stale because the compiler assures us that that is part of the code that gets compiled. So names are extremely important. So let's take a look at the name of a test. The naming pattern of a test differs from any other method name in our code base in that underscores are allowed. Why are underscores allowed? Because test method names tend to be very long. Why is that? Think about the continuous integration environment. Think about a service that has 200 or 300 tests. It's not unusual. Well, if we have 300 services, our continuous integration environment is going to push out 10,000 tests. If I can't look at the name of that test, if I can't look at the namespace plus the class name plus the method name to tell me exactly what's going on, well, out of 10,000 tests, I'm in trouble. I want to be able to look at the test name and know what went wrong. So get and lock calls cache. If that fails, I know that it didn't call the cache. Plain and simple. There's little or no other way to interpret what get and lock calls cache does. So that's a pretty good name in my estimation. Okay. The first thing I do here is I arrange, then I act, then I assert. So let's look at each one of these. We start by calling a outer variable. That variable is a mock. Now, if you don't know about test mocks, go out there, Google it. Pluralsight probably has something on it. Mocking is an extremely important part of our testing. Mocking, however, is expensive. So the higher we go in our test coverage, the more expensive it is per test, because the more mocking that we have to do. So what's mocking? Mocking is a technique that allows you to substitute some class for a class that really doesn't exist, a class that you can control. So let's look at this. We'll peel back the layers of the onion for the different pieces of information. The first thing we do is we go out to our test object factory, which is nothing more than a class that was created for the purpose of testing. This is not a some special pattern. It's just a matter of a class that I thought it was necessary to create just to make my testing more efficient. This is the mock definition. So let's just take a look at the mock definition for a second. I'm creating a mock of an interface called the local cache. Local cache comes from iCache, and here's iCache. So any class that implements iCache must, of course, implement these methods and or properties. When I say mock local cache.setup lambda get it is any of int, means that when there is a call to the get method of my cache object, and the call includes an integer of any, so 1, 2, 3, 4, 5, 0, -1, -2, any valid integer, I'm going to allow that method to be called. Let's look at one that actually returns something. Put and lock has an interface, put and lock, that takes a workflow and a key. And what we're saying here is that if I call this method with any workflow and any GUID, then that method is going to return a new put and lock response. And that's what mocking does. I could avoid a mock altogether by creating a fake by doing something like this. I think we have an implementation. Refactor is a way for me to implement this class. This should be rename, extract. No, come on. Implement. I have not used that in a while, so I guess I cannot find it. But there would be a way to do this, right? If I said public class fake cache, iCache. Oh, this is how I would do it. Okay. And then I would say, come on, implement. Where are you? Oh, good. Implement members. Finish. So my put and lock, let me find it. My put and lock, where are you? Return new put and lock response. Workflow repository error enum dot no error. So here I'm creating a class. We actually call it a fake, not a mock, that does the same thing as my mock would do. Return a put and unlock response when I call it with any workflow in any GUID. That's a perfectly acceptable technique, but it is a royal pain in the neck and a useless amount of time to spend when I can just use a mocking framework that I don't need to actually write code for. I don't actually need to create a real class for. I can just create a mock class. That's what mocking is. If you don't know the mocking pattern, then it's something you definitely need to research. So let's go back to my test. I set up my mock, and then I set up something called initial state, which is just some business specific rules. It's some state about the test. Nothing really important I want to talk about. So I have arranged. I'm going to go get something called a workflow repository. Again, nothing special I want to talk about. It's just, it's just part of my test. There's no pattern here that's special. It's just part of the business rules. And then I will take my repository and I will inject the cache factory, which is my local cache factory object. So let's go take a look at this repository a little bit more closely. This repository is a workflow repository. Let's go look at that. So my workflow repository, we can see that I'm using dependency injection here. If I were to new this class up using dependency and using the IOC manager, then what would happen is the IOC manager would inject each one of these objects. That's great during production. But what if I want to control one of these objects because I'm testing it, like the cache factory? I don't want to use IOC manager. I want to new up this workflow repository and then inject what I want to inject into it. Not what the IOC manager wants to do, but what I want to do to satisfy my test. In this case, satisfying my test means injecting or assigning the cache factory to my mock object. So now I have my workflow repository with my mock object. Then I will call the actual method. I will act on it and call my actual method. Let's see what the method does. So it does a bunch of things here. It calls cachefactory.create, cache.initialize. Let's see what I was trying to test. I was trying to test. I want to know that get and lock was called exactly once. So let's go back and look at that. And I don't see get and lock being called at all. So I would think, unless I'm wrong in what I'm trying to show you, let's just see. Let me make sure. GUID time span. So when I call this cache get and lock from my workflow report, oh no, I'm testing the local repository. Sorry, testing the local repository. So repo get and lock. Okay, so here's where I'm actually doing my my act get and lock. So let's go look at get and lock from my repository. Find space get and lock. Here it is. So I can see that this get and lock calls this cache.get and lock exactly once. That's what I'm testing here. I want to make sure that this method calls this class, this method, exactly once. So I'm going to call my mock object and say verify that get and lock was called with any GUID and any time span exactly one time. And if that is true, then the test will be green. And any other number, 0 or greater than 1, it won't be green. So what was the point of this test? The point of this test was just to make sure that the cache was called. That's it. I couldn't even, and if I wasn't mocking this, I would have to do something like this, get and lock. I would have to say, call count plus, and I would have to say public int call count, something like that. And then I would have to check that the call count is 1, comment that out, and now I could use a fake, not a mock. What a pain in the neck. I don't want to do that. I don't want to write that code. Fakes are very expensive to write, sometimes necessary, but rarely. What we want to do is mock. Okay, this is why 100% code coverage, another reason why 100% code coverage is expensive. It costs more because mocking costs more. All right, backing off a test that includes mocking. Trying to test something that is simple. Go ahead, somebody ask a question? No? Hemant?
Yeah, this is Hemant. John, so we are not using any mocking framework like Rhino or TypoMock. It's just that we are mocking the objects ourselves.
No, we're using a mocking framework. So if you look at this, we're using MOQ.
MOQ, okay.
Yep.
Yeah.
I was just trying to get
Okay.
the point across that if we didn't use a mocking framework, then we would have
It
to
would have been
write,
difficult.
yeah, we would have to write fakes, and fakes, as expensive as mocking is, fakes is 100 times more costly,
Right.
right?
Yeah,
So,
thank you.
sure. Okay, so let me get rid of my fake here. Now, a big point of engineering your code is to think about the test that you will have to write in order for your code to be easily tested. If I have to mock, then that's expensive. So I want to try to write my code in such a way that I don't have to mock. Okay, so how do I do that? Well, in normal scenarios, the single responsibility principle really promotes testing really well. Because if I have this situation, let's say I have class A and that calls class B, and it calls class C and class D. Okay. If class D doesn't call anybody else, then when I test class D, I do not need to mock. No mocking involved. If class C doesn't call anybody else, there is no mocking involved. I'm just testing the public method of class C. That's it. And the public method of class D. That's a very cheap test. If I want to test class B, then I have to mock class C and class D. Testing class B is more expensive because I have to write the mock. If I want to test class A, then I must mock class B. Mind you that I do not have to mock class C and D, because since I'm mocking one level down, since I'm mocking B, everything stops there. Stop. B does not call C and D because B is mocked. So if you ever get yourself in a situation where you have to mock more than one level, it is by definition wrong. Do not do that. I don't think, I mean, maybe you'll come up with a use case where you feel you have to do it. I would argue dramatically that you do not. If I have tested C and D onto themselves, then I never have to mock C from A. If I want to mock C from B, just so that I can verify how many times a method was called on C, then that's what I would do. I would run a test on B and then mock C and then find out its references. I would never try to determine the returns or test the returns of class C, ever, from a test from B. Why? Because I'm going to test class C and find out what the return values are directly without mocking anything, because nothing needs to be mocked in class C. Okay. General rule of thumb, do not mock more than one level down. Above that, try not to mock at all. You will have to, but really think hard about mocking before you do it, because it's expensive. And you say, John, well, how expensive? Well, everything is expensive to me. Everything we do. This training session is extraordinarily expensive because it's taking my salary and Haman's salary and Ashok's salary and Ken's and Lakshmi. It's expensive. So mocking is expensive. Simplify. Try to simplify as much as possible and put the thought into how you can simplify, because it's worth it. Because not only is it worth it for the first test you write, but who is ever maintaining that test, the return on investment goes up. The longer the life of the software, the more return on investment goes up. So make sure that your tests are named properly, that you do as little mocking as possible, that you are testing, at the lowest level and then up. And think hard before you write a test that ensures that C is being called from B. Think really hard if you really need to do that, because generally you don't. It's not a level of testing that I believe is worth it. In fact, I think it's detrimental, because refactoring, like we said earlier, is going to be much harder. So don't do it unless you really think you need to do it. Test C and test D. And if there's any return values out of B, test it. And if there's any return values out of A, test it. Now, one last thing. Let's say that we have an operation called do that calls this chain. We probably want to write one, what I would call smoke test on operation do to ensure that, the thing's just running. Operation do probably doesn't do much but call other people. I still probably want to ensure that, just does it run before I give it to QA? That's a good idea. Okay, I need to take a 20-minute break. So can we go on 20-minute break and we'll come back? Okay? And we'll probably do another 20 minutes.
Sure.
And we'll probably do another 20 minutes after that and then end it. Okay, great. Thanks.
Okay.
An integration test is a test that depends on some outside source to execute the test. Integration testing is more expensive, much slower than unit testing. The quintessential example of integration testing for business applications is normally testing against the database. It's a necessary evil, but it's something that we do less of than unit tests, except in the possible situation of access services, because access services, what they do is they hit the database. So let's talk about integration testing as it applies to databases. Let me bring up my notepad so I don't have to deal with the comments. Don't believe anybody that doesn't tell you that they don't do this and they think they do it right. Create a database, run your test, or rather, start by dropping database, create a database, insert seed data, insert test data, run the test. And then the next one does the same thing, and the same thing, and the same thing. And that's the only way to run a test against the database. Anything else and you're playing with fire. What do we do all day long in business applications? We normally get some state, we change some state, we test the change, and we repeat. That's what we do. So to that end, how do we do it? In order to show you that, let me look at the test space. You'll see that all of our classes will descend from test space. If they're a unit test, they will descend from a unit test space, and if they're an integration test, an integration test space. So let's examine that a little bit. So the test space will execute some test initialize, and it's decorated with the test initialize attribute, which means before each test is run, this method is going to be called. This is a standard line of code. What this does is it finds the database path. And when I mean the database path, every database, engineering, the engineering folder and the database folder, every domain, not every domain, but every database has a database folder. So let's look at one. We're looking at Chai. And the folder structure will be very similar in that there will be directories such as tables, and there will be one file for every table, and that file will have the DDL for the table. And what this test, so it not only has tables, but it has foreign keys and indexes and the whole thing. So it has the ability to create the database on the fly. And what it does is it will, in this case, we populate for Shy. Now you could have integration tests that run over 5 different databases. So you would potentially have 5 different statements here. This one just deals with Shy, so it says populate for Shy, gives the database path, and then there's a namespace called CPI. CPI was an old company of mine that did consulting years and years ago, and I still use libraries from that time in my life. They're very valuable and they do a lot for us actually. And in this case, this call will get the SQL files from the disk, and then it will get the test SQL file list. So that's something I didn't talk about. Let's just look at that really quickly. Shy. So you saw tables, and these are seeds. So let's take a look at a seed, see what that looks like. So this is data that is what I would call the seed data for the database. It's not test data. There's a difference. Seed data is data that is needed whenever a database is instantiated. It will insert such information like type information, in this case system types. That's what seed data is, and for every table that needs seed data, we will have seeded information. Okay. And then let's talk about test data. Test data is data that is created specifically for a particular service. So if I'm looking at, let me find one that, okay, here's hsbshy.PokerAccess.SQL. Whoever did this testing, in this case it was probably me, created test data so that I would have relevant information that I could utilize to test. We never combined services for our test data because very easily one service could override another service's test data and render the test useless. So every service that potentially uses Shy database will have its own set of data. And as you can see, these are all the services, and the name of the file is the name of the service that in some way tests the Shy database. So what this guy does is he gets all of the test files that are for the HSB Shy Poker Access.SQL, and it will populate the database. Populating the database means that we drop it, we recreate it, we run the seeds, and then we run the test data. And at that point in time, we have a fresh start to our database. We can absolutely 100% control the state of the database before we execute the test. And that is incredibly important. You have to know the exact state of the database before you can execute an integration test, or it could very easily be null and void. And then we do whatever it is that we're going to do to utilize that database in order to test it. There's not a lot of magic in there. The only magic one could argue would be the dropping and the creation of databases. Now that's an expensive operation, by the way, where you can probably run 100 unit test in a couple milliseconds, 5, 6, 7, 10 milliseconds. I mean, really quick stuff. Integration tests take like 4 or 5 seconds apiece. It has to drop the database and do all that. It might take 8 or 10 seconds. So integration tests are very expensive. It's a good thing that the number of integration tests are much smaller than the number of unit tests. That's good. Also, what's nice and what will be coming soon enough, Entity Frameworks has built an in-memory provider, SQL provider, so that we can, instead of moving the disk around to create the databases, those databases can be created in memory, and as such should be much, much faster. Now, here's somebody, I can almost hear somebody thinking, if you're paying attention, saying, but John, that's great, but you're really not testing the SQL database at that point. You're just testing against this mock database in memory. Yep, that's exactly what we're doing. We're not testing against the database. Why do I need to? Well, I'll have the conversation with myself since everybody's on mute. Why do I need to? Well, I need to ensure myself that the kinds of things I'm doing is applicable for the SQL Server, and the SQL Server is going to react like I think it's going to react. Yes, that's very true. But what are the chances that the SQL Server is not going to react the way you think it's going to react? Small. Remember, we're not looking for perfect software to send to QA. The chances are the SQL Server, we're doing simple inserts and selects and joins. And the SQL Server is going to react exactly the way you think it is. And I'm playing the probability game. And if it doesn't, oh no, there'll be a bug. All right, well then we deal with the bug. The cost is very high because we would spend a lot more time testing. Just the machines would be spending time testing. It's often that you write a class and then you test the class. If that includes an integration test, then I'm waiting. Look, one of the reasons why we made this particular service is kind of special, and it has 2 extra projects in it. But one of the reasons why I work so hard to have a solution that is so small is because of compile time. Think about what you do every day. You write some code, you compile. You write some code, you compile. You write some code, you compile. Well, if that compilation took a long time, then you wouldn't compile as much. If you don't compile as much, then what happens? You write more errors into your code. It doesn't react just functionally or syntactically or whatever it might be. It's not as, I bet you that I bet you that everybody on the call here hits that build very frequently, and you want that build to run very fast. If you're in a situation where you have 70 projects, not 7, then build's taking minutes instead of 6 and 7 seconds. The same is true with testing. You want those tests to run really fast, because if they don't, you're sitting around waiting a lot. We don't want to do that. So that's why I like that in-memory provider. And that's why I like unit testing much better than I like integration testing. Okay. I'm going to pause. Anybody have anything to say so far?
This is not related to the integration test. It's related to the unit test. Is it necessary to instantiate the IOC container when we are running a unit test?
So, great question. I'm going to pause for a second because I want to formulate my answer. Theoretically, in some situations, it may not be. However, it is probably necessary to initialize the environment. There's just a lot going on in the environment itself that you want it initialized. Now, you might say, but geez, I have a test and I don't need the environment at all, and all it has to do is add those 2 numbers. Why am I bother initializing the environment? because that takes time. And to that statement, I would say theoretically that's true. You're right. In that isolated fashion, you are correct. So if I really had that situation, then I wouldn't even descend from test space. I might write tests that don't initialize the environment. But here's the story. In reality, that's rarely true. It's in reality, you want the environment to be initialized, and as part of that, the IOC container is just part of that initialization. So it's a good point, and it's theoretically true, but in practice, I'm not so sure it's worth it. Certainly, if you find that you're in a situation where you really have the variables controlled that well, then I guess I'm not going to complain. The problem is that in our tests projects, it is the initializer code that the initializer class has the assembly initialize on it, the assembly initialized attribute. And that attribute will be executed at the beginning of every test run. And we're doing a couple things here. The most prominent of which is we are initializing the environment. I probably don't think it's worth not initializing the environment, because a lot depends on that, logging and all kinds of things. So that's not a direct answer, but it's just one that has probability involved.
Yeah, John, I noticed like, okay, most of the test cases, or the unit test cases, we are using the mocking framework. So, and IOC being a dependent library or a dependent external system. So maybe this, what do you call this, assembly initialize where we are initializing IOC, and of course we are initializing the NHibernate profiler. This is applicable to the integration tests and not for the unit tests.
I mean, certainly,
yeah.
You're certainly right about the NHibernate profiler. That's true. I think that's such a fast command that it doesn't matter. Plus, believe it or not, there was a bug that we found in NHibernate that actually needed the initializer to be executed. Now, again, you could argue in unit tests it doesn't matter. So I guess what I'm saying is I will definitely entertain those thoughts. They're not bad ones. What I don't know is how much time it's going to actually save, and if it is really worth it, and what the side effects might be of not initializing your environment before you execute tests. For example, if there's an exception thrown or something, and there's a log message that goes out, well, that's going to choke, because it's part of this is it initializes the logging mechanism. In theory, what you're saying has a lot of merit. It really has a lot of merit. I just don't know in practice if it is worth it to deal with the hassles of not initializing and what kind of time that's going to save you. But good thought. Try it if you want. Absolutely. And report back to me your findings. And that's something that potentially we would incorporate. But see, that's Ashok, for so many reasons, that's a good question. For so many reasons, because it's not something you just like made up on your own. It's something that you're bringing to my attention, and we're talking about it. And if you do and it's successful, we'll make it part of what we do, period. So great question. Experiment if you want.
Yeah, sure, John. I'll experiment and let you know. And I have a meeting. 1 second. I have a meeting in the next 5 minutes, John.
Yeah,
so
I do too. I'm going to end it. I'm going to end it now because I have a meeting too. So guys, we'll pick this up on. We'll probably have another training session tomorrow, unless there's any other questions right now. then we'll pick it up tomorrow. Okay then.
John.
Yes.
Okay, John. Yeah.
Great.
Okay, thank you.
Thank you.
Thank you, John.
Bye.
Thank you.